I've had a question from Hannah who says, how does this relate to epigenetic mechanisms influencing the baby? And I realise that you're not an obstetrician, but obviously the microbiome spreads a little bit further than just the colon, doesn't it?
Yeah, so it does a bit. So I'm not an neonatologist, but increasingly through my work, what we've begun to understand is that understanding microbiome interactions and microbiome host interactions in very early life is the key, really, to understanding why younger people get bowel cancer. And just to deviate before I answer Hannah's question, that's important to me because we see dramatic changes in the epidemiology of bowel cancer in young people. Millennial generations now have a risk of bowel cancer 4 times that of people born in the 1950s and 60s and 70s, and that rate is climbing. And that has to be understood in the context of the changing epidemiology of other chronic diseases that are seemingly unrelated, but in terms of the science I've just described, are very related. So, for example, allergies, immunities, inflammatory bowel diseases, rheumatoid arthritis, mental health problems, all of these things are climbing, and they're all happening in younger people. And our hypothesis is that part of the reason for that is because we are losing the microbiome. We are seeing basically a mass extinction event of the microbiome. And that, of course, is key because it means our immune system then cannot simply keep up with the industrialized world. So epigenetics, for those of you that are listening that aren't too familiar with it, is the science of post-translational modification of genes. So you're born with a gene, it has a programmed function, of course, that gene can mutate in some way, and that function will change. But even after that gene is set, its code can be modified by external factors. Some of those things can be in our environment, so it might be toxins or pollutants, but microbes can also change these gene functions. And bacteria, we're beginning to now understand how bacteria cause epigenetic modifications, and we've got some good examples of that, inflammatory bowel disease being really quite a good disease, where we've got some evidence of it, for example. So bugs, do absolutely cause epigenetic modifications. Some of those things might be in infancy, some of those things might be during gestation. The problem is it's super hard to study in human systems, of course, because to study it, you have to do something invasive, and that's really very difficult. So much of this work also comes from animals. So it is my belief, and we've just picked up on one of those kind of main themes there, which is, I think, a kind of core hypothesis from my work, which is that I do believe that we're experiencing an internal climate crisis. I believe that many of these diseases really need to be considered through the spectrum of climate change. And because the microbiome is a living system, it's a living organ, it's living microbes that are populated within us through our interaction with the environment, it is a literal and figurative connection to the outside world, to the climate around us, to our external world. So when you damage one, you damage the other. We can talk about mechanisms through which the microbiome is being damaged internally, but I absolutely believe it to be important. And there are multiple mechanisms through which the microbiome will influence our health, epigenetic modification just being one.